Hey, welcome back to our Algebra 1 series. This is the first video in our Algebra 1R lesson series. In this 1.1 section, we're going to talk about equations, expressions, inverse operations, solutions. So an equation is just a statement that two expressions are equal. So what is an expression? An expression is any combination of numbers and variables. So maybe, for example, an expression would be something like 3x plus 5, or w minus 7, or 3y, or negative 8. Those would all be expressions. An equation is a little bit different, and the equation differs from an expression in that an equation has an equal sign. So maybe you have 2x equals 9. Or, I don't like 3, let's go with 5b plus 6 equals 31. So any, any equation is saying that two parts or two expressions are equal. So 5 by itself is an expression, but when you add in the equal sign and say x equals 5, now I have an equation. 2x is an expression, 9 is an expression, but if I put them together with an equal sign, I get an equation. Our solutions are just any values for the given variable that would make that equation true, that would give me a true statement. And in order to get a solution, I need to use inverse operations or opposite operations. So I always think of opposites. We do a little game usually at the start of class where we'll talk about, the opposite of up is down, left is right, Batman is Joker, the opposite of White Sox is the Cubs, the opposite of the Bears is the Packers, that kind of thing. So I need to know what opposite operations I'm going to use to undo something to get my variable by itself, because in algebra we're always solving for our variable. In this first problem, that variable is w. So I'm going to split this up into two parts. I see an equal sign. I'm going to split this up into two parts mentally. Here's one part. There's one expression. And here's another expression. And I want to get my w, my variable, by itself. So in order to do that, I need to get rid of anything that's in the same side of the equal sign or same side of the equation as that variable. In this case, it's the positive 4. So how do I get rid of the positive 4? I have to do an opposite operation or an inverse operation. I see positive 4, I need to do negative 4. And I'm going to do that opposite operation to my positive 4, and I'm going to look for like terms on the other side. Here's a like term. Those are just nice whole numbers. So anytime you have just a nice constant number, you can subtract your numbers, and I get w equals 12. On 2, same idea. I see my variable x on this side of the equal sign with a negative 7. In order to get x by itself, I need to undo that negative 7, which means I need to do a positive 7. I'll look for another whole number or another constant on the other side. I see one there, so I'll add my two numbers together, my two terms. And if I see negative 12 plus 7, that can be kind of hard to do. But I can do 7 minus 12 a lot easier. That's just easier for my brain to do. So I'll think of this as positive 7 minus 12, which would get me a negative 5. And our last one here, a little bit more confusing, but it's the same process. Over here on the left side of the equation, I see my variable w, and I see a negative 15. So here I have a positive w, or a positive 1w, and a negative 15. And to get rid of that negative 15, it's still the same idea. I need to get rid of that by doing the opposite of a negative 15, finding its like term, doing the same thing to the other side of the equal sign. And now I have 1w, or w equals 21. So I have w equals 21. Another way you might solve this is maybe you don't like having the w in the middle of the equation rather. So maybe you put your variable out front. I have a positive w, or positive 1w, and I'll just rearrange these. Keep the negative with the 15, and then it's the same process. I see a minus 15, so I'll do the opposite operation, the inverse operation, and w is still 21. So either way, you still get 21 as your final answer. And you can plug that back in and check your work, and you'll still get the same thing. You'll get a true statement. All right, I would encourage you to try 4 through 7 on your own. You might get some decimals, and that's okay. But let's pause the video, try 4 through 7 on your own, and then unpause. We can talk about 8 and 9. So on 4, again, the most important question to ask yourself to get started is, what operation do you see? I see multiplication here, so I'll do the opposite. I'll divide. And my z should be a negative 6. Positive divided by a negative is a negative. On number 5, I see this y. To get my variable by itself, I need to get rid of that minus 9. So in order to undo subtraction, I need to do addition. And I'll look for its like term over here, the other side of the equal sign. Negative 2 plus 9 is kind of hard to do, but I can do 9 minus 2 in my head, and that's 7. So y equals 7. And on number 6, I've got 7 cubed is 38.5. This is where we might get a decimal, and that's okay. Decimals are just fine. I see multiplication, I'll do division, and q would be 5.5. And then 7, here's where my brain has to work with these numbers. I don't know what 31 divided by 4 is. That's kind of hard for me to do. But what I do know is what I can do to break up 31. So maybe I know that my multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32. Well, the closest one I can get there is 28 without going over. So I know that if I were to divide 31 by 4, I'm going to get some decimal. Let me break this up. 28 divided by 4 plus 3 divided by 4. 28 plus 3 would get me back to 31. And I can do a little bit of mental math here. 28 divided by 4 is 7. And I can add my 3/4, or 7.75. If you have 3/4 in your pocket, you've got 75 cents, or 0.75. All right, 8 and 9, it's the same idea, right? We just see division now. So if I see a fraction is really division. And if I see division, I'll do the opposite of dividing. I'll multiply to get rid of that division. And then I've got 11 times 3 is 33. That would get me Q. And here, negative times a negative is a positive 30. So N would equal a positive 30. All right, there's our one-step operations. On the next page, I would check the answer key. But let's talk about our words here. Some key words that mean addition. We got more than, we got some, subtraction would be your less than, or difference. Difference is one that often gets people tripped up. Difference can sometimes be confused for division for some reason, but it's really a subtraction problem. Multiplication would be the product of or times, if I said 3 times as many, and division would be quotient. So I would look at the answer key, the completed notes on the Google Classroom page for 12 through 17, and then, send me an email, stop by in the morning or briefly after school if you need some help, or ask me for a pass to the math lab, and I will